Good morning guys, welcome to BDA's Online Academy tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do well to press subscribe button and notification bell in order to see all of our educative videos online. Thank you and God bless you. Today I will be considering Chemistry JAMB 2021 solution. Chemistry JAMB 2021 solution. And the paper type before us here is type B. The first question here says, which question paper type of chemistry is given to you? Which question paper type of chemistry is given to you? As you can see here, we have type B. So option here is type what? B. So we have type B here. Now that's our answer. Number 2 question. What is the concentration of a solution containing 2 grams of sodium hydroxide in 100 centimeter cube of solution? What is the concentration of a solution containing 2 grams of sodium hydroxide in 100 centimeter cube of solution? Now we have to calculate concentration here. Concentration in mole per what? In mole per dm cube. Now concentration in mole per dm cube is given as what? Is given as mass concentration all over what? Molar mass. So this is the formula for calculating what? Concentration in mole per dm cube. Now how do we get our mass conc and molar mass? Now we are told that what? The solution contains 2 grams of sodium hydroxide. So in order to get our mass conc now, we have to use mass conc equal to what? Mass over what? Over volume. Now this volume must be in dm cube. We are given that this solution contains 2 grams of sodium hydroxide in 100 centimeter cube. So we take the volume to what? To dm cube. So V is equal to what? 100 divided by 1000. So when you divide it now, this 0 cancels this 0. You have 0.1 dm cube. Now this is dm cube. So now we can now calculate our mass conc, which says that mass over volume, which is 2 over 0.1 is equal to what? 20 grams per what? dm cube. 20 grams per dm cube. So that's that about mass conc. Now then we need to calculate the molar mass of sodium hydroxide as well. So the molar mass of sodium hydroxide now will be equal to 23. Sodium hydroxide contains sodium 23. Atomic mass of sodium is 23 plus the what? Oxygen is what? 16. 16 now, we have 16 here, plus what? The hydrogen is 1, which is equal to 40 grams per what? Per mole. Now we've calculated what? The mass conc, the molar mass. So we go back to the formula, initial formula, which is what? Mass conc over molar mass, which is what? 20 grams over what? 40. Now how many 40 grams in 20 grams? It will be what? 0.5. And the unit of what? Molar concentration is known as what? Mole per dm cube. So the final answer here is what? 0.5 mole per dm cube, which is option what? Option B. So that's option B for us. Now look at this question here. Which of the following properties is not peculiar to matter? Which of the following properties is not peculiar to what? Matter. Now kinetic energy of particles increases from solid to gas. We are talking about the properties of individual state of matter. So if you want to understand this question and get the question right, you need to understand what is the individual properties of solid, liquid and gas, because these are the 3 states of matter that we have. So now let's check. Now provided we have a container containing solid, liquid, then what? Gas. Now how does the liquid or solid occupy this container? Now if we consider solid consists of what? Closely packed what? Particles. It consists of closely packed particles. So closely packed particles which does not allow free movement of the particles. Now when we are considering liquid is a little bit spacious, more than what? More than solid. It is not that closely packed together. As you can see, there is a space which allows a little bit of movement. But when you look at gas consists of what? Small molecules that are spatially spaced. Now, this is what we call gas. You can see there are a lot of space in what? In gas. So, the kinetic energy in solid, this is solid. We have solid here. The kinetic energy in solid is kind of very small. It's very small. While the kinetic energy in liquid is medium, and while the kinetic energy in gas is very high. So, the increase in kinetic energy is from solid to liquid, then to gas. So this is very correct. Now, being random motion of particles increases from liquid to gas. Yes, this molecule in liquid here, they move slowly and in a more orderly way than in gas, because gas consists of smaller particles. They will move in a zigzag manner, in a random manner. So they didn't have a specific way of flowing. So unlike liquid that flows in a specific direction. Now that's that. Number B is also correct. Now see, orderliness of particle increase from gas to liquid. Orderliness. Now the one that has the least orderliness here is the gas. So that's why they said it increases from gas to liquid. So the orderliness of gas is very is the least, followed by the liquid. While the orderliness of solid is very high because they are closely packed together. Now the third one, orderliness of particles increase from the gas to liquid. Then the D option says random motion of gas. The random motion of particles increases from gas to solid. The random motion of particles increases from gas to solid. Now, look at this now. They say random motion of particles increases from gas to solid. Meaning that they are saying that gas is the least particle that is random in motion. No, which is not true, because gas are in a constant rapid motion. Because that is one of the theoretical kinetic theory of gases. So gas are in a constant random motion. So meaning that they have the tendency to move in a constant random motion than any other particles of the matter. So that is why D is not correct, because they said that the gas has the least random motion of particles. So which is not correct. So this is not peculiar to matter. It's not peculiar to matter. Now that is that about that. So the question says the principle of polar chromatography is based on the ability of the constituent to dash, A, move at different speed in the column, B, dissolve each other in the column, C, react with solvent in the column, D, react with each other in the column. Now look at this very well. The principle of polar chromatography. Chromatography is used to separate different particles in a mixture by use of their solubility. Now, but chromatography, we use the rate at which individual particles in a mixture to separate them. The rate at which individual particles in a mixture travels along the column to separate the particles contained the mixture using polar chromatography. So, in polar chromatography, the speed of the travel of each particles or each constituent in a mixture is used to separate them. The one that travels faster will be collected first, followed by the next one that is also fast, that is also fast next to the first one. So they use the movement of a particle and the speed to separate mixture of particles in a chromatography. So the answer here is option A. Move at different speed in the column. So it is very important. The principle of polar chromatography is based on the ability of the constituent to move at different speed in the column. So that's why we have what? In chromatography we have what? The solvent font and the what? Solid font. So that's that. So the question number 5 here says that from the diagram above, an ideal what? Gas. An ideal gas. So an ideal gas can be represented by, now look at this very well. We have K here, we have L here, we have M here, we have N, and we have what? We have this is what? Graph of PV against what? P. Now, as you can see here, the graph here, which is of L, this straight line, this inclined line here, which is what? Which is line L here, increases. It increases with pressure. You can see that the line increases with increase in what? In pressure, meaning that what? The pressure is not constant. It's not constant. So that is not an ideal gas. Now, an ideal gas has a pressure of 760 millimeter mercury, or it can have 1.2 atm atmospheric pressure at constant. So its pressure will not change. While you can see that this gas of K, this gas K here, for us experience what? Decrease in pressure, then later becomes to what? To increase its pressure. Now also the same thing happens to what? M here. If one first decrease, then it increase. But when you look at this graph N here, is the only what? Is the only gas that maintain a constant what? Movement with even what? Increase in pressure here. So that's why it's an ideal gas, because it is not affected by change in what? In pressure. So that's why line N is what? Is an ideal what? Gas. So an ideal gas. Which of the following properties is correct about periodic table? Now, when talking about periodic table is a table that contains all the elements according to the what? Increasing atomic number. So when I talk about periodic table, let me just sketch periodic table for us here. So when we have periodic table like this, so we have the vertical. Now here I want to sketch the first 20 elements, so as to understand this very well. So we have what? A sketch of what? Of a periodic table here. So now here we have the group, then we have the period. Now here we have 1 to 8 group. Now we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, then we have group 8 here. Now, where this period column now, we have period here, the period run from what? From the horizontal, it's a horizontal line. So we have period 1 here, period 2 here, period 3 here, and so on and so forth. Now, we have group along the what? Vertical axis now. This is the group that runs vertically. That is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, and this one is period 1, period 2, period 3. Now, here we have what? Hydrogen usually behave like metal and non-metal, but can put that group 1. This one is what? Helium. We have the what? The lithium here, the boron here, the beryllium here. Okay, the lithium, the beryllium, the boron, the carbon, the nitrogen, the oxygen here, the fluorine, then what? The neon. Now here now you can see that this is the sketch of the diagram for periodic table. Now, which of the following question is not correct, or which of the following is not correct about periodic table? Which of the following is not correct about periodic table above? Now, the non-metallic properties of element tends to decrease across each period. Now, is that correct? The non-metallic properties of element tends to decrease across each period. Look at this. From period 2 year we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. You can see that this is more metallic than beryllium, and beryllium is more metallic than boron, boron is more metallic than what? It means that what? The non-metallic properties even what increases as we go across the period. So meaning that this is not what? This is not correct. So it cannot be our answer because the which you're following is correct about periodic table. Now this is not correct. Now the valency electrons of the element increases progressively across the period. The valency electrons of what? Of element increases across the what? The period. Now yes, this is very correct. The valency electron increases of element increases progressively across the period. The valency electrons of element increases progressively across the period. You can see that in lithium we have what? The valency of 1 electrons. In beryllium we have the valency of what? 2 electrons. In boron we have the valency of 3 electrons. In what? In carbon we have the valency of what? 4 electrons. You can see that the valency electron increases progressively from 1, 2, 3, 4, 5, 6, 7 and 8 along the what? Period. So our option here is B. Our option is B. So now the question number 7 here says that the relative atomic mass of naturally occurring lithium consisting 90% of what? Lithium and 10% of lithium. Now the relative atomic mass known as what? Denoted as RAM, our isotopes, which is 90% of 6 lithium and 10% of what? 7 lithium. Now these are isotopes. Isotopes are elements that have the same atomic number or different what? Mass number. Now to calculate the relative atomic mass of what? Lithium, now we need to find the 90% of lithium 6 plus 10% of lithium 7. So what do we have here? 90% is also known as what? 100 multiplied by what? 6 plus 10 over what? 100 multiplied by what? 7. So this one will give us what? 0.9 times what? 6 plus 0.1 times what? 7, bracket it. So when we add them together, this one will be equivalent to what? 6.2. So this is 6.2. So option what? 6.2, option C. So 0.96 times 6 plus what? 0.17. 1 times 7 is what? 6.2. So option what? C. Now an isotope has an atomic mass of 15 and a mass number of 31. An isotope has an atomic number of 15 and mass number of 31. Now it has a atomic number. Let's denote that isotope with what? With S. Atomic number is 15 and mass number is 31. The number of proton it contains is what? Look at this. Atomic number is the same thing as the number of what? Number of protons. Atomic number is the same thing as number of what? Protons. So when we're talking about atomic number is equivalent to what? Number of what? Protons. So the number of protons here will be the same thing as what? 15, because the atomic number is the same thing as what? Number of protons. Now the molecular lattice of iodine is held together by what? The molecular lattice of iodine. Now I don't have molecular lattice of iodine. Iodine is what? It's an electronegative element. Know that iodine is an electronegative what? Element which form what? Which has a bond like this. Now a bond that holds the molecular lattice of iodine together is what we call van der Waals force. It's a weak force. It's a weak force that holds them together, and it's specifically London force. But London force is part of van der Waals force. So the option here is D. So that is that about question number 9. The arrangement of particles in crystal lattice can be studied using what? The arrangement of particles in crystal lattice can be studied using A. X-ray, B. Gamma ray, D. Alpha ray, C. Alpha ray, D. Beta ray. The arrangement of particles in crystal lattice can be studied using X-ray, gamma ray, alpha ray, and what? Beta ray. Now look at this, we are dealing with what? The arrangement of particles in a crystal lattice, usually an electrovalent compound. Is because it's only electrovalent compound that usually have what? Crystal lattice, usually from crystal lattice. We can study using what? X-ray. The crystal lattice has these characteristics of what? Of X-ray what? Diffraction. So we use what? X-ray to study crystal lattice because they diffract what? X-ray. Crystal lattice diffract what? X-ray. Example is what? Is sodium chloride. The crystal lattice of sodium chloride diffract what? Diffract X-ray. So when I talk about crystal lattice, it's how the ions are being arranged in the what? In the formation. So that's that about that. Now number 11 says that number of moles of solids against what? The temperature. This has to do with solubility. Whenever we see what? Number of moles of solids against what? The temperature, that's to solubility. We are here, this represents the solubility curve. On the diagram above, find the amount of what? Solids deposited. 1 200 centimeter cube of solution is cooled from 55 degrees Celsius to 40 degrees Celsius. We should find the amount of solid, that is amount in moles, while it is cooled from 55. Now this is where we have temperature 55 here. Now the solubility of the substance is depending on what? On the temperature. So the temperature is cooled from 55 degrees Celsius. So let's trace this to the graph. Now trace this to this. So we have this one. We have a point here now. Let's trace it. Your mind, so these are around what? 6 point something. Okay, 5 point something. Now let's trace this what? 40 upward. So this is, so also we have what? So this is the what? So we have here, we have around this piece here, we have, you can see that this, when you look at this scale here, this is what assumed to be 0.2, 0.2, 0.2, 0.4 and so on and so forth before we can get to what? 2 here, because 0.2 times 10 will give us what? 2. So now if this one is 5.12, if this one is 5.0, if this one is 5.0, then it is assumed that this place will be 5.2. So you assume that it will be 5.2. So the difference is solids. The difference in the amount of solids here will give us what we are looking for. So 5.12, 2 mole minus what? 5.0 mole is equal to what? 0.20 mole. So here we have what? 0.2 mole as our answer. So that's how we do that. We trace this one down up here and trace it back. So, and that's how we get that for 0.2 mole of substance will be dissolved when the temperature is lower from 50 degrees Celsius 40 degrees Celsius. Now, the importance of sodium aluminate in treatment of water is to cause coagulation. It causes coagulation. It causes particles that are inside the dirt in the water to coagulate, to come together for filtration. So we use sodium aluminate to coagulate all dirty things in water for in order to filter it off. So that is the function. It causes coagulation of substance in water, of dirt, especially dirt. So now, what type of bond exists between an element of X with atomic number of 12 and what? And with atomic number of what? 17. Well, now what type of bond exists between an element X with atomic number of 12 and Y with atomic number of what? 17. What type of bond? Now when you write what? Atomic number of what? X with atomic number of what? 12. When you write the electronic configuration, we have what? 2, 8, 2. Now that of Y, which is 17. This is 17. We have 2, 17. This is 2, 8, and what? 7. Now this one has what? 2 electronic atom shell. This one has what? 7 electronic atom shell. So it means that it requires 2. This one has 2 electrons, so it has to donate that 2 electrons to this. So this one will need what? We need to duplicate itself in order to receive this what? 2 electrons, because this one is it needs what? One electron to complete it what? Its electron structure. So, and this one is donating 2, so it has to duplicate itself. So we have what? X, Y, 2. This is a complete transfer of electron to what? To Y. So there's going to be what? Because they said what type of bond is between what? X. X is an electropositive element, and this is an electronegative element, which is the transfer of electrons from metals to non-metals, or the transfer of electrons from electropositive element to electronegative element. It is what? Electrovalent to what? Bond. That is a bond that requires the transfer of electrons from metals to non-metals, or from electropositive element to electronegative element. Has to do with what? Electrovalent what? Compound. So that's that about that. The hardness of water is mainly due to the presence of calcium hydroxide or magnesium hydroxide, calcium carbonate 4, or calcium tetrachloride 6, sodium hydroxide or magnesium hydroxide, calcium chloride, or sodium sulfate. Now, the hardness of water is mainly caused by calcium carbonate or calcium sulfate. So the hardness of water is caused by calcium carbonate 4 or calcium sulfate. So this is the best option that you can take: calcium carbonate, that is CO3, then or calcium sulfate or calcium sulfate. So that's that about that. So calcium carbonate or calcium sulfate. So that's that option B. Now, this is suitable solvent for iodine and what? Naphthalene. Is suitable solvent for what? Iodine and naphthalene. That's question 15. Is what? Iodine and naphthalene. And naphthalene is an organic compound. Inorganic is an organic compound. While iodine is what? Is an inorganic what? Element. An inorganic compound as well. Okay. So that's suitable for them is what? Question number 15 now. A suitable solvent for iodine and naphthalene is dash: A. Carbon 4 sulfide, B. Ethanol, C. Water, D. Benzene. A suitable solvent for iodine and naphthalene will be what? Benzene, an organic what? Solvent. Benzene, an organic solvent that dissolve iodine and naphthalene. Please note that dissolve what? So that's that about this lesson. Please, if you haven't subscribed to this YouTube channel, please do well to press subscribe button and notification bell in order to see all of our educative videos online. Thanks for watching once again, and God bless you. Amen.